Hi, I'm Merlin Glynn. I'm a technical product manager at VMware. And today we're going to do part 2 of a 2-part lightboard series on Pivotal Cloud Foundry and vSphere. So if you were able to view the first part of this, this is where we have our existing drawing. As we covered what is Cloud Foundry. And we see that we already have our applications running inside of Cloud Foundry and services are being consumed. So our applications being our AIs. So now we're going to focus a lot on what does vSphere actually give, or what does vSphere solve for Cloud Foundry to keep it running, keep it highly available, keep it performant, keep it secure. So what are the key things? We're going to ask we're going to try to answer that in this lightboard session. What are the key things that PCF needs from its IaaS, or infrastructure as a service? So Pivotal Cloud Foundry, what does Pivotal Cloud Foundry need from its IaaS? So there's really three key things that we're going to focus on here. The first is that we need to have scalability. We need to have scale. So scale, in aspects of looking at Cloud Foundry, there's a lot of ways Cloud Foundry will scale, but some of the key things that you want to pay attention to is our application instances. If you paid attention in our first series, we could scale pretty easily. We can actually run a CF scale command for one application like myapp.foo.com and have hundreds of application instances. But these application instances are actually running on VMs that are instantiated in the infrastructure. And there's a particular type of VM. So when we look at these application instances, they're going to run on something called a Diego cell server. So we're just going to use the acronym DC for Diego cell server. And we're going to have multiple Diego cell servers. But these are VMs that are pre-created that our applications are being scheduled to run on. So when we start to increase and we start to horizontally scale our application instances, or maybe even make them larger, we'll have a need to consume more infrastructure. So it's important that we have a construct underneath Cloud Foundry that can actually scale. And so the construct we're using on the vSphere side are clusters. And we'll talk a little bit more about availability as well, because these clusters come in to be an availability construct as well. So these are going to be our vSphere clusters. And inside of our clusters, so we'll just call this one cluster 1. And we'll create cluster 2 and cluster 3. We'll just call them C2, C3. Now inside of these clusters, we're going to have a resource pool construct. And a best practice is to align a single installation or a single deployment of Cloud Foundry to a resource pool in a cluster. This allows us to have, across a common infrastructure, allows us to have multiple deployments of Cloud Foundry. And it also gives us a construct at a vSphere level if we have to do some resource limiting or resource granting or reservations. So with our resource pools, these are the units that we have to look at scaling. If we have to add more capacity, i.e. more Diego cell servers to run more applications, we have to have an easy construct that we can grow that. And so with our vSphere clusters, we can easily add hosts or expand our hosts and storage underneath the hosts dynamically without having to affect the uptime of Cloud Foundry. So this is an action that could take place without affecting Cloud Foundry itself or its applications for scalability. So that's a really key thing, is to have that type of concept to scale horizontally and vertically, depending on what the needs of Cloud Foundry are going to be. And it's not just our application instances. We may have other types of jobs that we might have to scale. For example, some of our logging jobs, which we'll talk about in a minute. So that's really one of the key things we want to look at is scale. So how do we solve that, or one of the ways that we solve scale is to take a look at our cluster constructs. Now, another key thing that we need to look at is availability. So Cloud Foundry, remember we talked about BOSH in session 1. BOSH has the capability through its agent to detect the health of all of these jobs and make sure that those jobs actually stay running. So if we have one of our Diego cell servers go down, which is where our applications are running, we can actually repair that with Cloud Foundry. In addition, we can use things like vSphere HA, which will help reduce the downtime in case of a physical failure or in case of a VM being shut down. So those are some things there are two technologies that work together. They have to be scheduled appropriately so that they don't step over each other, but they're two technologies that work together to ensure that our actual job instances are made available. Now, another thing about availability is the availability zone constructs. If you remember in session 1, we talked about how application instances are aligned to availability zones. Well, all the key components of Cloud Foundry, all the components that allow routing to take place, which is another type of job, and that's going to be called the Go router. So we just use GR for Go router on these other types of VMs. We want to have these Go routers be available as well, because the Go router will actually be able to balance or load balance across our application instances across our availability zones. So we need to make sure that those are highly available as well. So that's why with BOSH we want to deploy these jobs or these roles of Diego cell server and Go router across multiple AZs. So if an AZ were to fail, I still have the major key components that the rest of my Cloud Foundry instances can still run, and Cloud Foundry itself can still publish applications. And the way that winds up looking is if you look under our resource pools, we'll have VMs that actually get instantiated. So we'll have a DC for Diego cell server instance, and we'll have a Go router instance in each one of our availability zones. And so these applications that we're publishing here, for example, on the myapp.foo.com, since we have 3 availability zones, we should actually have those application instances published to 3 separate clusters, to 3 separate Diego cell servers, and 3 separate physical fault domains. So that's one way that availability is provided in Cloud Foundry, but it's not just all about the VMs. And this kind of goes back to scale, too. We really have to take a look at how healthy is Cloud Foundry? How healthy is the infrastructure hosting Cloud Foundry? Are there problems that aren't necessarily surfacing that are related to a VM object? So the way that we do that is we want to monitor Cloud Foundry, which is really key to maintaining scale and availability. So Cloud Foundry has something called the fire hose, which is the way that we can tap into Cloud Foundry and to other components, which this lightboard session isn't to the architecture of Cloud Foundry, but how we host vCenter and vSphere around Cloud Foundry. So we can dig into fire hose in another session. But the fire hose is basically where all things like events and metrics are exposed and made available for the entire foundation, all the components, all the BOSH instance jobs, all the application instances. They're emitting events and metrics outside of the fire hose. And what happens is we want to consume those metrics, and we want to do something meaningful with them. So this is where vRealize actually comes in to solve a unique problem for operating Cloud Foundry. And that Cloud Foundry is really powerful and a really complex distributed system that deployment of has been made simple by using BOSH, but the management of day 2 operations of can be quite complex and wieldy unless you are actually looking at these emitted events and emitted metrics to make sure that everything else is running the way, make sure everything is running the way you would expect them to run, not just the way BOSH would expect them to run. So with vRealize, we have 2 key components, vRealize Operations Manager, or VROPS, and this is where our metrics are going to tie in. And so it's really key, some of these key metrics inside of Cloud Foundry show the application instance growth pattern. How fast is my Cloud Foundry implementation actually being consumed by developers and tenants pushing all these applications? Can I trend? Can I look to see how I need to grow this capacity underneath in order to host all these AIs? And so that's a really key thing in maintaining availability, because if you run out of capacity, you are in essence running out of availability in Cloud Foundry because you can no longer push applications. So it's really key to look at the metrics. In VROPS, there's a solution package, or solution integration package available for VROPS that gives us a nice dashboard with some of the KPIs or key performance indicators of Cloud Foundry so that we can really maintain or get a view of the health to operationalize Cloud Foundry. Now, in addition, it does us no good to just look at the Cloud Foundry metrics, but in addition, we want to take and ingest the metrics from our IaaS as well. And so having that in one place to combine view of what's happening at the IaaS layer, what's the pressure on my VMs, what's the health of my host, but also what's the health of my Cloud Foundry is a really key component for long-term trending, availability, and runtime, or uptime of your Cloud Foundry deployment. Now, these, the combination of our multiple availability zone infrastructure helps us answer number 2. How do we maintain availability? So proper divisioning or proper partitioning of our physical fault domains and using vSphere constructs, in addition to actually taking a look at what's happening at the IaaS layer, monitoring these metrics from Cloud Foundry, and putting them together in a single pane of glass is really key from an availability perspective and uptime. Now, the last thing that we really want to look at from our infrastructure is security. So all these applications can be pretty complex, especially when you have hundreds of applications running on a Cloud Foundry, on a single Cloud Foundry instance. So we have to make sure that we provide a secure way and an auditable way for us to run our applications. So the first thing that we're going to look at is, in addition to our compute and storage that are being exposed here in our clusters, we're also going to have a networking layer, software-defined networking layer provided by NSX. Now, we won't go into detail of Cloud Foundry networking. That's something we're going to do in another lightboard session. But there are various layer 2 networks or logical switches that have to be deployed to allow these services to function properly in Cloud Foundry. And one of the key things that Cloud Foundry needs to run is a load balancing service. It needs something to be able to take requests in and forward them to these Go routers. That's why we called out these Go routers earlier, these particular job instances, because these Go routers are the jobs that route inside of Cloud Foundry so that we can get a route request from myat.foo.com to that particular application instance. So we have our NSX edge that's capable of doing load balancing for us, as well as NAT services. A lot of Cloud Foundry deployments, NAT services is a key security concept, which again we'll go into deeper in networking for Cloud Foundry. In addition to SSL. In our load balancing, we can actually do SSL offload at the NSX edge. And these are things that most Cloud Foundry implementations need and require and are typically serviced externally. So having that embedded as part of the infrastructure, as part of the SDDC infrastructure, providing your services to Cloud Foundry is a really key thing. And that gives us, at least from a network control point, that gives us ACLs and auditability and network tracing. But in addition, it's not all about the infrastructure. It's the same thing with monitoring. It's not all about the infrastructure if you're going to maintain security in your environment. You have to actually also audit events. You have to know what's happening if applications are being shut down, who they're being shut down by, what's happening from a log trail from the applications themselves that may be emitting out of the fire hose. So these are the events that we talked about. So events are some key bits of information as well that will come off of the fire hose. And those events, we want to ingest those in vRealize as well. But the component we're going to use is going to be called vRealize Log Insight. So it's really key when you talk about securing any cloud platform, whether it's Cloud Foundry or a Kubernetes deployment, it's really key to look at how do you control from a network access perspective, but also how do you audit, how do you report on access, because that's a really key thing for people who are working in compliance and security. So here you have what we can give Cloud Foundry from an availability perspective, from a scalability perspective, and from a security perspective to run efficiently in production with a cloud scale, cloud native application environment, Pivotal Cloud Foundry. So I hope you've enjoyed these lightboard sessions, or the second of these 2 lightboard sessions, and that's it. Thank you.